All right, so my name is Carly Stoughton. I'm a technical marketing engineer with the NCMA business unit, which handles the 9K ACI and our Nexus 3000 product line. I've got about 200 slides for you today. Just kidding.
Fantastic.
This is all I'm going to show you, and we're going to go to the whiteboard. I tell people when they ask what I do for a living, I draw pictures. So let's enough with the architecture. We're going to get technical. I know that's what you guys are here for. So let's go ahead and get started with that. So I would like to first talk about understanding the policy model. So what makes ACI special? One of the things that differentiates us is that policy model. Starting to think about networks in a different way than we have in the past. Right. So let's take a look. We're going to start over here. So with the policy model, what we want to start thinking about is really the needs of the application. Right? Who's on the network? What do they need to talk about? And who can talk to who? Right? Instead of thinking about configuring 20 routers, 50 switches, firewalls, load balancers, right, all these different devices individually that may have different operating systems and may have different teams that we're configuring. Right, we want to just make it simple. Right? Who's out there? Who can talk to who? And what are they allowed to talk about? So we're going to start by kind of looking and breaking down holistically what an application looks like, what the pieces of an application are, some of the terminology that we use in ACI so you guys can start to get an understanding of how it actually works. And then we'll look at how those pieces connect and tie into our spine leaf architecture with the Nexus 9000s. So when we think of an application, we typically start thinking about front-end web tier. All right, maybe this is my SharePoint application and this is my front-end web interface. All right. And then I have my users. We'll say this is my user Billy Bob here. And yes, I like to draw, but no, you're not going to get anything more than a stick figure. I cannot draw more than that for you. But we'll have our users, Billy Bob here. It's going to be talking to our front-end web tier. But we've got a little more going on. So we think of that first when we start to break down holistically what an application looks like. But we've got a little more going on. So I've probably also got some application servers that are presenting up to my web tier. What am I missing?
Database.
Database. Yeah, I probably have a database also on the back end that's serving up information for the other tiers of my application. So those are the main pieces when we try to look holistically of what an actual application, again, something like SharePoint or a typical 3-tier application, this is typically what we think about. I may also have some things like shared services, right? Things like Active Directory, DHCP, DNS. So we'll go ahead and add those in as well. So now we have kind of a picture of what an application looks like. Basic 3-tier app. This is not what every application looks like, sure, but this is a simple model that we can look at. And yes, we don't always know what our applications look like, even if we're an application person. But this is a basic layout of the different tiers that we have, different pieces of an application, the who of what's in the data center. That's the first part that we're figuring out. And what we call each of these clouds that I've drawn up here in the ACI policy model is EPGs, endpoint groups. Okay. First acronym. We'll have a few. I'll make sure I call those out, but that's what we call endpoint groups. Collection of endpoints that are going to need similar treatment on the network. So then, that's the who, but with ACI, we're again thinking about networking in a different way, and ACI is actually a whitelist model. So by default, at ACI, on an ACI fabric, none of these guys can talk to each other until we explicitly allow them to. Okay, very different from our traditional Ethernet networks, kind of plug it in, spray and pray, broadcast, spanning tree, same thing we've been doing for 30 years. So different with ACI. Right now, if I had just defined these endpoint groups, nobody's going to be talking on the network.
How do you define the endpoint groups? Are these VLANs? Are these MAC addresses? Is this 5 tuples? Is it all of the above?
So there are multiple ways to do that today, and there are more coming. The ways that we support today is to sort things into these buckets that we call endpoint groups. We can do this based on VLAN, which is a very easy way to do it. That's the way we've seen a lot of our initial customers do it. You know, web, anything in web is in VLAN 10, anything in app is VLAN 20, database is VLAN 30, right?
And that maps into VMware port groups, and we are done, right?
So I will have another session that will discuss the VMware integration, but that is another option. We can also look at things like tags, other tags besides 802.1q tags. We can look at VXLAN tags. We can identify traffic based on NVGRE tags. We can do physical port and say maybe anything that comes in on this port, I want to be part of my web endpoint group. And then I can also do virtual port. So leading into your question about integration with VMware and port groups, we can also sort things into these buckets using virtual ports.
Would that require AVS on vSphere host or not?
Does not require AVS. That's an option, but we could use a standard. We can actually push in a VMware distributed switch. And that I'll cover in another session. Yes. So those are some ways that we can sort things into these endpoint group buckets. We can also do things like static endpoints based on, say, a MAC address. We're also going to be doing cool things down the road. One of the ones I'm really excited about is virtual machine attributes. So maybe I could say any VM that starts talking to my fabric here that's called production-wildcard. Put that into a certain endpoint group. And that's just one of the ones that's coming. So these are the ones that are supported today, and we're going to have others down the road.
Just a question on that VXLAN there.
Sure.
Does that mean if the hypervisor is using VXLAN ANCAP, like using
Yes.
VCNS, for example, you would be able to look into that and then do filters between endpoint groups based on the payload of the VXLAN packet?
So the intention more with VXLAN is, let's say this is a VMware server here, and I'm actually doing VXLAN inside of the hypervisor, and I'm applying a VXLAN tag to the packet. It's looking for that specific VID, or that specific VNID on the leaf. Yeah. Or NVGRE tag if we're in a Microsoft environment. So, yeah, VLAN, that's certainly a common one. That's one we've seen a lot of customers start out with, because sure, we don't always know what an application looks like, but if we're networking folks, we probably know which VLANs sort into which groups.
And it's closer to the current connectivity model.
Right, and that's normally how we think about that. And we are changing how we're thinking about networking. What's actually happening on the fabric here is different than we do in the traditional Ethernet world, but frankly, it's time for a change. All right, who likes spanning tree? Oh, we got one.
Because if you understand it, you can be like the genius guru guy.
Yeah, but nobody does.
It currently beats
Well,
the
obviously he
alternative,
does.
or sucks less.
I will challenge that.
Sucks less. That's a good.
Easy, isn't it? Loop, take one out.
Yeah,
That's it.
It's great.
Come on now.
go unplug the cable. You're good to go. Right, so there is a lot more that we're doing on the fabric itself here. Things like taking off the tags, putting on our own tags, running an overlay technology, using standards-based protocols on this actual fabric, eliminating the need to do things like flooding across here, like we have to do in normal Ethernet networks. That's one of the innovations that we have in the Nexus 9000 that's actually happening on this fabric here. Other questions so far? Okay, so let's talk a little more about this policy model. So we talked about endpoint groups. Those are the ways that we support today that you can sort things into these endpoint groups. VLAN, NVGRE, VXLAN, physical port, virtual port. All right, so I have my endpoint groups, but again, whitelist model. Nothing can talk until I put policy in place. And the way that we implement policy in ACI is in the form of what we call contracts. So I need to put contracts. That's the who can talk to who and what can they talk about. We've got the who. Now we're going to put in, again, what we call contracts. Which can be unidirectional or bidirectional. So for example, I want my users to be able to talk to my web tier. I want those endpoint groups to talk, but I don't need the users to go talk to the databases. All right, I don't need to add that piece in.
These contracts can be packet filters or traffic redirection, right?
Yes, so in the contracts, there's multiple actions that you can take. You can do things like permit, deny, redirect, log, copy. Those are the different actions that we can put inside of a contract. And it's easiest when we get started with a build with ACI, when we go and roll this out with customers, is we'll start by permitting all traffic between two endpoint groups, and then we can narrow it down from there. Because I probably only want, maybe Billy Bob here, maybe I only want him to be able to come in on ports 80 and 443. So I can start to get pretty granular with what I'm permitting, and I can have multiple subjects that are allowed in this contract so that I can limit what they're allowed to talk about.
And because you're doing this in hardware on the switch,
Yes.
you're effectively limited by what TCAM can do, which is up to layer 4, right?
Right. So essentially with ACI, since we do a whitelist model, it essentially gives us a stateless firewall. Now, if you want to do stateful inspection, yes, we still need a separate firewall. But by having this whitelist model, it really gives us this stateless firewall out of the box. But we will be able to integrate, and we do support integration with some layer 4 through 7 services today. So Citrix, F5, ASA, ASAV, right? More of that coming, but yes, if we want to do stateful inspection, we're still going to need something like a firewall.
Now, as I look at this, some people might become rule happy. So they will just build loads and loads of rules in the contracts between the individual tiers. Eventually, you might run out of the hardware resources on the switch. So what happens then?
So the nice thing about this policy being implemented is it's also dependent on where the devices are. We're only going to program these rules into the TCAM on the switches where these devices, these endpoints actually live. So if I don't have any web servers connected to this leaf, those rules aren't going to be programmed into TCAM.
But if the web server virtual machine moves over there, then the controller has to push down the new.
Yes, then it will push the rule into TCAM.
That's not. I thought that we said earlier that the controller didn't have to push out that at the time.
That was my next question.
So
yeah, that was about saying that the controller's pushing out like a new policy or whatever as such, but if it's workload migration, then that should be dealt with within Fabric without requiring the controller?
So, correct. So the controller, which is a cluster of 3, that's simply a policy repository. That's where we configure these policies and where they get pushed out. There are 2 different ways that you can have policy pushed out. You can either do immediate or on demand. And if we do immediate, it's going to go into TCAM. If we do on demand, it's going to go into one of the hard drives that are sitting on these APICs, which are essentially UCSC series servers.
So if you are light on resources, you can go for immediate, and then it gets deployed everywhere. And as you start running out of that, then you go for on-demand, which requires controller in the real time, but allows you to survive in cases where you're sort of close to the TCAM limits.
Let's see. Let me think on that one for a moment. So you're saying if we had, say, a complete controller failure and we had a VM move, would that policy be present? I believe that it would be pushed already to the hard drive that's present on the leaves. That's something I would want to check, though, and get back to you.
So you have hard drives on the leaves.
Sorry, not the hard drives on the leaves, the memory on the leaves.
Okay.
Yeah, the memory. Yeah.
So it would be, I guess, each leaf knows about the policy. It's just whether it's installed that in TCAM or not.
Okay, so it's like you push the config to the switch, but the config is not used until you actually have some need for it, in which case it gets into TCAM.
Right. Or
you
if,
guys
unless
do,
you
guys do this on the existing switches. Come on.
that one I can't help you there. Yes, if immediate though, it would go to TCAM whether or not we needed it. Yeah.
So I've heard that as sort of conversational learning, to use a former term.
Right.
Yes, yeah, the way that we're actually learning the endpoints and the way that we can make sure that we're not flooding here. So the spines know where everybody lives. The leaves know who's connected to them and who they've talked to across the fabric, which is similar to conversational MAC learning like we've heard about in technologies like Fabric Path.
Yeah, but it's topology driven, not traffic driven, right?
So it could be both. It depends what kind of integration you're doing. But the moment I have, say, let's say this is a bare metal server, the moment I have a packet come in here, the leaf is going to say, okay, who are you? Are you web? Are you app? Are you database? And we're actually going to tag in our headers across the fabric the source EPG because we have to enforce this policy that we have here. Yep. Yeah, so the leaves are really the ones that are doing the policy enforcement.
Can we go one level deeper?
Yes.
If I have a contract between a web and app EPG, and then I have all sorts of other contracts, I might get into this state explosion where I have this enormous number of rules because of all these different contracts. Are you somehow optimizing that so that half of the processing is done on ingress and then half of the processing is done on egress, or do you do everything on the ingress as the packet gets in?
So ideally, we do policy enforcement on ingress because why pass a packet across the fabric that we're just going to have to drop when it gets to the other side? Granted, sometimes I know the source EPG, but this leaf may not have spoken to the destination EPG. In that case, we have to send it across the fabric so that we can do the enforcement when it gets to the destination leaf. but we want to do what we call opportunistic policy enforcement. So I want to drop the packet as soon as possible if it's not allowed.
So you only send it out if you don't know who the other guy is.
Right. But either way, it's 3 hops. That's
Yeah,
the
sure.
beauty of the spine leaf topology, is that whether or not I know the destination leaf or not, I have to hit a spine anyway. So it's a 3-hop, predictable latency, predictable bandwidth. That's why we have this architecture.
And when it's sent across to the other leaf, it's done on ingress there, right?
Which piece?
So if one leaf hasn't talked to the other leaf, we don't know the destination, and it's sent across, and then it's enforced on the other leaf. It's
Right.
done on ingress on that leaf, right?
So packet comes in,
Fine.
and I don't know the destination endpoint group. That would have to go across the fabric, which would be equal cost multipath across the fabric. Spine is to know where everyone is. So then the spine is going to go ahead and send that to the destination leaf. Leaf is going to learn. Because the source EPG is tagged, and this guy knows all of his guys. So he's going to look at the destination and say yay or nay.
Now a tricky one. Sorry, but the
Go for
scenario
it.
just-
Go for it. I love it.
So let's say you're sending the packet to the right spine. The leaf doesn't know where to go, so it sends packet to one of the spines. Let's say it chooses the right one. And the link between the right spine and the right leaf is down.
Okay. This link?
Yeah.
Okay.
What can the spine do now? It cannot reach that leaf, and it's stuck there with the packet, looking at the packet. What will it do?
So if just that link is down,
Yes.
we still have another path.
Yeah, but the left leaf didn't know that.
But the spine knows that.
Okay, so how does it get the packet to the other side?
So the spine can send it back over here
Oh, okay.
and over to the leaf.
That would only be a short-term micro loop type situation, wouldn't it? Because presumably, if you lost that link, it would pretty quickly the network would reconverge around that. But yeah, it could be a micro loop situation, I guess. Yeah.
And the link failure detection is actually 125 microseconds.
Yeah,
So
if you
it's
started-
very,
It really only happened if you started serializing a single packet. Yeah, I mean, you only get it if you had serialized a single packet. It's already going across that wire serialized, and you lose that link at that while it's serialized and going across. It would be like a packet or two.
right, exactly. Yeah, because we're not doing protocol-based, we're not waiting on timers and protocol-based convergence. That's one of the innovations that we built in to the Cisco ASICs that we have on the Nexus 9Ks. That's why we have this hardware solution as well. So, yep. All right, let's make sure we finish covering the policy model here. Great questions, though, on the fabric architecture, and we have a lot more information on that that's available. So contracts, nothing to talk till we have these contracts. I can permit all, I can reuse contracts. I can do actions like permit, deny, log, redirect, copy, are all actions that are supported within these contracts.
What level of statefulness, like when you're doing port level filtering like that, what level of statefulness is there?
So we can do ports, protocols. You can also do as down to TCP state. So
Like header flags and stuff like that, established or whatever. That
Yes.
sort of thing.
Basic
Yes.
layer 4.
But
Yes.
it's all stateless at that stage,
yes,
right?
stateless. Yeah. We're not totally replacing firewalls here. Yeah, if we want to do deep packet inspection, we want to do stateful filtering, then we need a firewall, but we can integrate firewalls and have those programmed from the APIC. Yes. So I can say just Billy Bob here is only allowed to talk to the web servers on ports 80 and 443. But I'm probably going to want to do a little more than that. And maybe I don't totally trust Billy Bob here. Maybe I'm going to want to have a firewall. Maybe I'm going to want to have a load balancer. So again, getting back into that layer 4 through 7 service insertion, I can actually add within this contract what's called a service graph. which is essentially a service chain. And I can say, first you're going to go through a firewall, then you're going to go through a load balancer, then you're allowed to talk to the web tier. So I could either do that by redirection, or if I've integrated a device like the ASA, then I could have that inserted right here in the service graph. So all of that can be contained in a contract that's reusable between tiers, between tenants, between different applications.
If you send a packet through layer 2 firewall, then obviously the MAC address doesn't change, so you know it's the same packet. But if you send the packet through a load balancer, it appears as a totally different packet on a different VLAN with a different set of source and destination IP addresses when it comes out. So how do you know that it's still that same packet that is bound by that same contract?
Let's see. So if we had redirected to, we'll say this is a load balancer, if we'd redirected and we changed, so defining an EPG doesn't have to be just one of these things. So maybe you would include both of those VLANs in that EPG definition.
So you would include the VLAN coming out of the load balancer into that same definition?
Yep. Yeah, because you can, an EPG I can have, because for example, and we'll have a session on looking at different ways to set up these, but my databases, some of these might be VMs, some of these might be bare metal servers, some of them might be Hyper-V. The key is it doesn't matter. So in a single EPG, I could have devices that are running on different platforms.
The contract at pool on the load.
Yeah, but that's a
That second
different
half, which is-
contract.
Yes, exactly. Second leg.
Yes, the EPG, so I would put both of those VLANs, the inbound and ingress and egress, same EPG definition.
You probably have to split this into two domains, because if you put the output of the load balancer in the same EPG as the users, what prevents that packet to go through the load balancer again because of the contract?
Well, once it's already passed through the load balancer, it's going to be aware that the traffic came from the load balancer, and we're going to be able to go ahead and forward it on to the fabric. So all of this definition, this could be, say, this is my production SharePoint application. All of this, these EPGs, our endpoint groups, the contracts, the definitions of what we have in here, all of that is what we call an application profile. So ideally, I would have an application profile for each application I had out there on my network. And these are very repeatable objects. Each of these can be exported as a JSON or XML file. Everything is essentially a hierarchical object through our RESTful API. So I could export this application profile, make a couple changes, push it back in. I don't have to be a developer to do this. There's a tool, there's actually a plugin called Postman in Google Chrome that allows you to push and post back through our controller into the API. So very repeatable, programmable, but this is essentially what we get with the policy model is let's think about who's out there, who needs to talk to who, and what are they allowed to talk about. That's what we get with the policy model.
You have something like read-only mode, where you could figure out what's actually going on and tracking the sessions, and then you go like, now I hope I'm 100% done, now let's push this.
Yes, you could do something like span between EPGs. The beauty of this is we'll see in some of the other sessions that provide demos. But we'll see that everything has a health score that we can monitor, and we can actually see that at an application level. So instead of just looking at a switch or a port or a link, when someone picks up the phone and says, I can't access my email, I can go look at my Exchange profile, look at the health score, and start drilling down and seeing what the problem is. Troubleshooting a lot easier because we're thinking about it at the application basis. It's definitely a shift in how we think about traditional networking, but this is going to make it a lot easier to roll out new applications, make changes, help us kind of decouple all of these networking concepts that we've mushed together over the years in the OSI model.
One other thing just crossed my mind. Sorry about the questions.
No. That's what I'm here for.
You said that one of the actions you have between the EPGs and the contract is copy. How granular is that? Can I say, well, I permit packets to port 80, but I permit and copy packets to the DNS port?
So that one's still being worked on. So we'll see more on that coming.
Okay. I was hoping for a fabric-wide span.
Span we can do. Yeah,
but
span you can do
intelligent on the
EPG to
port
EPG.
numbers.
Yeah. So it's, definitely makes it easier to troubleshoot because I can look at between these two applications, and it's on an end-to-end basis, how is that application performing on the network?
So you can do span today?
Yes.
The regular port-to-port span?
Yes.
But you can't yet do the contract-based span?
The copy action in a contract is coming.
Okay.
Yeah. But span is there today, yes. So that's really the policy model. And again, all of this you would configure in the APIC, which is our controller cluster of 3 devices. Open API northbound and southbound. GUI is one way that you can interact with it, or we could use Python. Right? It's an open API. So GUI is
You have to have a minimum of 3 APIC devices?
in production. We do have lab bundles that you can get that have 1 APIC though.
What's the reason for that?
The reason is for redundancy. And actually all 3 APICs are active, and all of the data is actually sharded across all 3 APICs, which I hate that I have to say that word, but all of the data is sharded across all of the APICs. Right now, 3 will be able to scale out to more APICs in the future if we have a larger environment that has a lot of policy.
Doesn't have anything to do with like split brain or making.
So the reason it's 3 is so that we have quorum. Right. We only had 2, we wouldn't have that ability. Right. We only have 2 people
you don't
voting.
Have split brain.
Yeah.
You know which part of brain you kill.
Yeah, so 3 gives us quorum. Again, all active. I could go to any one of the 3 APICs and configure from there. And the data is sharded across all 3 APICs.
So you can work with APIC through the UI or through the API. Is there any chance that I could get something out of APIC in a text file so that I could use that for version control or diffing or something like that?
Yes, absolutely. So, and we encourage backups, but there is, yes, that's part of the GUI. You can set up automated backups of either partial configuration, entire configuration of the whole APIC. I can take that, I can push it into a different fabric somewhere else. Or I can export individual objects. And if I just want to take this EPG and replicate it somewhere else, I can right-click, save as, and it'll give me an XML or JSON formatted version of that object. Yeah, so essentially the APIC is really, it's the API that we're going through. So the GUI is really talking to the API.
Yeah.
Homebrewed.
It is Cisco GUI, but it does, you could write your own, right? Since we have that API is open both northbound and southbound, you could have your own device or interface that you write that's programming the APIC, and the APIC is also capable of programming other devices, like the ones I mentioned that are supported today. So you could write your own tool if you wanted to.
What is the GUI? Is it?
The GUI we will show in a separate session, but we'll get a little peek at the GUI. Yes. All right. So that is the policy model. That is an application profile. That is what we're starting to think about now in terms of networking, is we want to bring the language of the application to the network.